everyone. Guess what we are going to talk about today? Trees. I know we have been learning about our best friends since childhood. They have made possible all life on earth by emitting oxygen, absorbing carbon dioxide, build up our food, give us numerous necessary products such as wood, medicine, you name it. Of course, without them we are doomed. But no, we will look into some other quite less known aspects of their usefulness today. That is how they tell the story of our beautiful planet. No, not just as fossils, when they are pretty alive and well too. Surprised? I bet you would be. Let's dive deep into it then, shall we? After all, we should know everything we can about what our besties do for us, right? Okay, so let's get started with today's topic then. Today we will talk about tree rings and how they help us know so much about the world that we live in. The growth layers of trees appear as rings in the cross-section of the tree trunk and record evidence of disastrous floods, insect attacks, lightning strikes, even earthquakes that occur during the lifespan of the tree, thus holding some of nature's most accurate evidences of the past. Each year, a new growth is added to a tree's girth, and that is called a tree ring. The most recently formed tree ring is the new wood near the outer part of a tree's trunk, just beneath the bark. The oldest rings are smaller and near the center. Tree rings are easier to spot in mid to high latitude regions because they have a distinct alternate light and dark banding. Tree growth depends upon local environmental conditions such as water availability and the length of the growing season. In areas where the amount of water varies from year to year, scientists can use tree ring patterns to reconstruct regional patterns of drought. Trees will produce wider rings during wet and cool years than during hot and dry years. Drought or a severe winter can cause narrow rings. If the rings have a consistent width throughout the tree, it implies the climate was the same. The thickness of the tree rings can also indicate when growing seasons were longer, that is during warmer times, and when growing seasons were shorter, that is cooler times. The study of the growth of tree rings is known as dendrochronology. The study of the relationship between climate and tree growth in an effort to reconstruct past climates is known as dendroclimatology. A tree ring representing 1 year consists of 2 layers. A light colored layer which forms in the spring and early summer, which is typically thicker because the tree is growing. A dark colored layer which forms in late summer and fall, which is typically thinner because the tree's growth slows. Tree ring data is only collected outside of the tropics. In temperate latitudes, trees grow in the spring and summer and are dormant in the winter, which creates the distinctive pattern of light and dark bands. Tropical trees grow year-round, thus they do not have the alternating dark and light band pattern of tree rings. Scientists extract core samples using a borer that is screwed into the tree and pulled out, bringing with it a straw-sized sample of wood about 4 mm in diameter. The hole in the tree is then sealed to prevent diseases. Old trees tell us about conditions on Earth long before people started measuring and recording the weather. One tree species, the bristlecone pine, lived for several thousand years and contain long records of tree rings. However, climate scientists typically work with trees that are not so long-lived and extend their tree ring records back more than 10,000 years by comparing ring patterns of living trees with the rings in dead but not yet decayed trees. Beams from old buildings or ruins, samples from wooden frames of old paintings, and even the wood from violins are all used to add tree ring samples to climate records. Older tree rings in petrified wood have also been analyzed to interpret what the climate was like hundreds of thousands to millions of years ago. Now let us look at some examples. A study which brought out a 226-year-long chronology of teak trees from southern Myanmar showed that intense floods and droughts have periodically occurred in the region. Another interesting study by Somaru Ram from Indian Institute of Tropical Meteorology, Pune, showed that increasing heat index and mean temperature during summers in Sikkim has had an adverse effect on tree growth due to high potential evapotranspiration. Evapotranspiration is the rate at which plants lose water through their leaves. Such studies help scientists understand the impact of climate change at the local scale and also its impacts across countries and continents. So that was a brief insight into the topic. We hope you really enjoyed this video and it truly helped chronology and dendroclimatology and maybe even kindled a bit of interest in these not so famous fields. We look forward to keep on making more works like this in the future. Thus until next time, thank you and goodbye.